Now let us talk about the real stuff. How to create charges in nature. I tell you that friction is one of the most basic method to create the charge in nature. Rub two objects against each other. Then what happens? You'll have to apply a force of certain magnitude continuously in order to keep rubbing those two objects. Why do you have to apply this force? To overcome the friction acting between those two objects. So it means that when you are rubbing those two objects, you are doing some amount of work. So work is done by the external agent. Why the external agent requires to do the work? In order to overcome the friction, he has to apply the force. So work is done by the external agent. Who is the external agent? You, who is rubbing those two objects against each other. And what happens to this work done? Whatever work or the energy you are supplying in this process, what happens to that? When we rub two objects against each other, they get heated. Just rub your two palms against each other. What happens? You feel heat. So this work done by the external agent results in the form of heat, and this particular energy is received by the electrons of the objects. The amount of work which is done by you, that results in the form of heat, and that energy is received by the electrons of both objects. And out of those objects, suppose one particular object has a less tendency to hold on to the electrons than the other. That means a lesser amount of energy is required for the electrons to escape from that material in comparison to the other. Then what will happen? The electrons will be first transferred by that object into the another object. So the transfer of electrons will take place in this process. And so the object which loses the electron becomes positively charged, and the other objects which gains the electron becomes negatively charged body. One more thing that I would like to tell you at this point, that just consider there is some conducting object. Conducting object means there are several free electrons roaming around inside the material boundaries. Free electrons means those electrons which are not bound into a nucleus, because these electrons has got energy sufficient enough to escape from the clutch of the nucleus, and they can roam around inside the matter boundaries. But hold on, these electrons are not so free that they can escape from the metal boundary. What will happen in case these electrons try to escape from the metal boundary? The moment one electron, suppose, escapes, then the remaining material will be positively charged, which will attract back that electron into the metal. So what is required here? Energy is required to overcome that force of attraction if you want the permanent removal of electron from this material. So now we understand that the permanent removal of electron, we need to give certain amount of extra energy to this electron in order to overcome the force of electrostatic attraction caused by the parent object. So in some cases this energy requirement is less, and in some other cases it is more. So that is why in some cases electrons are loosely bounded to the parent material in comparison to the other. So they are the losers of the electron. The other one receives the electron and becomes negatively charged body. So this way, using the method of friction, we can create two objects, and these two objects are always oppositely charged with the same magnitude. That is for sure. So what is the most basic method? That is the frictional electricity. Means we use the method of friction in order to create charged bodies. And once such charged bodies are created, then using these bodies we may apply certain other tricks also to create other charged bodies. I'll give you some examples related to this frictional electricity. The first example, just remember, So when ebonite is rubbed against the animal fur, then what happens? Animal fur can't hold on these electrons as strongly as the ebonite. So when these two materials are rubbed against each other, then because of the heat produced, energy absorbed by the electrons inside the animal fur will first escape and enter to ebonite. So this way the ebonite will be negatively charged and animal fur will get equal amount of positive charge. The net charge remains zero. Remember the conservation of charge, that net charge in the universe is constant. But do you remember that we cannot take the guarantee of individual positive or individual negative charge or the number of charged particles. So here is next example of the glass rod with piece of silk. So one material is glass rod and the other one is the silk. So when these two materials are rubbed against each other, then in this case silk holds onto the electrons more strongly than the glass. In this case silk has got more holding capacity for the electrons in comparison to the glass rod. So electrons are ripped off from the glass into the silk. So glass attains positive charge and the silk attains negative charge. So at this point of time you must be thinking that, oh, it is very difficult to remember that which material is going to lose the electron and which one is going to gain the electron. That's true, because it depends on the pair. It's not that silk is always going to receive the electron. Maybe with some other material it may lose the electron. You have to remember the whole pair. The first example was ebonite with animal fur. Just try to remember some of the examples first. That when we rub animal fur against the ebonite, then we know that animal fur is unable to hold on to the electrons as strongly as that in case of ebonite. So electrons are transferred from animal fur into the ebonite, and which results the positive charge for the animal fur and negative charge for the ebonite. And in this example we have one material is the glass and the one is the silk, and when these two are rubbed against each other, then glass loses the electron because it can't hold the electrons as strongly as the silk can. So silk is negatively charged and the glass attains the equal positive charge. So just try to remember these two pairs. This is known as the electrostatic series. Materials are arranged in a definite order. Suppose here it is first sulfur, brass, copper, ebonite, paraffin wax, silk, lead, fur, wool, glass. So in this order, if we write these material, then from starting, if you see that this is the increasing tendency to hold on the electrons. That means ebonite has got a more tendency to hold the electrons in comparison to the wool or in comparison to the fur. So when we rub ebonite with the animal fur, then what happens? Animal fur loses the electron and ebonite receives the electron to get negatively charged, and the fur becomes positively charged. In the same way, if we rub glass with the silk, then silk has got more tendency to hold on to the electrons, and that is why silk will get negatively charged and the glass receives the positive charge. So maybe this particular electrostatic series may solve your problem to how to remember this, but at least you'll have to remember this particular order. And hold on, just mind it that in case you are reading in some book, suppose you encounter with the electrostatic series, then it may be the case that it is totally reversed. Here we have entered sulfur at the first place, but in some other book it may be the case that glass is at the first place and sulfur is at the last. Why? Because then these two rules will get reversed. Are you getting me? If we reverse this series, then the rule of losing or gaining the electron will get reversed, because from glass towards the sulfur, there is an increasing tendency to hold on to the electrons, and from sulfur to the glass, there is an increasing tendency to lose electrons. So you have to learn this series that way, that from sulfur towards glass, there is an increasing tendency of losing the electrons. So if you can remember this series, then it might help you to attain a couple of extra marks in the examination in some objective question. If suppose it is asked that copper is rubbed with a lead piece, then what happens? So as you know that copper has got more tendency to hold on the electrons. So copper gets negatively charged and lead will receive the positive charge. And the same case is with when lead is rubbed against the brass. Brass will gain the electron, lead will lose the electrons. And in the same way, there are several pairs which can be made out of this electrostatic series. So hopefully, this particular series will solve your problem to remember that how do we decide which one is going to lose the electron and which one is going to gain the electron. So this way, the problem can be solved, but at least you will have to remember this particular order. Means sulfur, brass, copper, ebonite, paraffin wax, silk, lead, fur, wool, glass. That is the increasing tendency of losing the electrons, or the reverse, increasing tendency to hold on the electrons. So that is how it may work for you.